Hey ChemStars, this is Mrs. Vanderlein bringing you another ChemStar video. And today what we're going to do is talk about the molar mass of an element, okay? Or the molar mass of a compound. So what I need you to do is pause this, make sure you have your periodic table, make sure you have your calculator, and come right back. Alright, welcome back. So I want to refresh your memory, and I'm actually going to go flipping back to page 3. That's page 5. Here's page 3. And remember when we talked about this, alright? So from the periodic table, we said 1 mole of aluminum was 26.98. We said that 1 mole of iron was 55.85. We said 1 mole of carbon dioxide was 44.01. Wait a minute. Carbon dioxide is not on my periodic table. Do you remember what we did in class on page 4 to figure that out? And then we said 1 mole of calcium was what? Here's calcium. Look at that real closely. It says 40.08. And we put in 40.08 here. Do you remember doing that? Well, that's what we're going to be doing more today. So last time we talked in page 5 and 6, and we said that 1 mole has 6.02 times 10 to the 23rd particles. All right, so we said here 1 mole, I even write it in again, is 6.02 times 10 to the 23rd particles. And what's a particle? A particle can be an atom. If it's an element, we have an atom. We have nitrogen gas, we can talk about being a molecule. If we had copper ion, it could be ions, all right? So it can be anything. And we said it could be rice grains. It wouldn't be practical, but we could do it. We could say it could be, oh, I don't know, pennies. It wouldn't be practical. There's not that much copper in the whole world to make that many pennies, but we could, talk about it. But what makes sense is to have this huge number. Do you remember how big that number is? That's the number. So here's 1,000, million, billion, trillion, quadrillion, quintillion, sextillion. All right, if you think about our national debts around here, we're talking about, trillion times our national debt. All right, so this is a huge, huge, huge number. So why talk about that many huge, or huge number? We need something really, really, really small to count something really, really, really big, okay? And that's when we count small atoms and small molecules. But what's the problem? Can I see an individual atom of carbon? Can I see an individual molecule of nitrogen? The answer is no. I need an awful lot of that stuff for me to hold it in my hands. And so that is why I'm going to turn the page now. We're going to talk about the molar mass, okay? Because now I can actually hold this in my hand, okay? So it says the atomic mass of an element expressed in grams, all right? That's important. Why is that important? Because I can weigh out grams. I have a balance to measure out grams with, all right? So it's something I can physically do, all right? Is the mass of the mole of an element. In other words, that's 6.02 times 10 to the 23rd atoms of the element. So if I were to sit here and count 6.02 times 10 to the 23rd atoms of carbon, it would weigh 12.01 grams. Well, folks, one atom weighs 12.01 AMUs, atomic mass units. All right, so 1 mole weighs 12.01 grams, so I can use grams per mole as my unit. Okay. All right, what about silicon? Hey, let's look at my periodic table. Here's silicon right over here. All right, it looks like 28.09. I know I kind of drew on it, but 1 atom weighs 28.09 AMUs. So 1 mole, if I can get out my scale and measure out 28.09 grams, I get 1 mole. So I broached this question earlier. Why, if these have the same number of particles, does silicon weigh more than carbon? Each of these, if I were to weigh out 12.01 grams of carbon, it has 6.02 times 10 to the 23rd atoms. If I were to weigh out 28.09 grams of silicon, it would have 6.02 times 10 to the 23rd atoms. So why does this weigh more? Well, what makes up an atom? Protons, neutrons, and electrons. Well, guess what? Carbon has 6 protons and 6 neutrons and 6 electrons. Silicon has 14 protons, roughly 14 neutrons, and, well, okay, 14 electrons. So guess what? You weigh more, or more protons are going to weigh more than 6 protons. All right, 14 neutrons are going to weigh more than 6 neutrons. So that's why these AMUs are different. And if you multiply this by 6.02 times 10 to the 23rd, you're going to get a difference in grams. All right, so let's finish this off. So here's my copper. Copper's right here at 63.55 AMU. So that's 1 atom of copper will have that many atomic mass units of mass, all right? But if I have 6.02 times 10 to the 23rd of those, it's going to weigh 63.55 grams. So I can use the unit grams per mole, okay? And then finally, tin. I actually used some tin in class the other day as an example. Was 118.71. And let's see here, that's how much 1 atom. Wow, tin has a pretty large mass. Wonder why that is. Well, it looks like tin has, ready, 50 protons. Watch this. It has roughly, I don't know, 69 neutrons and 50 electrons, all right? So it has a lot more protons, neutrons, and electrons than carbon does. Well, it has more mass than, doesn't it? So if I have 6.02 times 10 to the 23rd atoms of tin, it weighs 118.71 grams is 1 mole, so my unit is per mole. All right, so that would cover anything that's on the periodic table. All right, so if it's an element, I can just directly look off the periodic table and voila, I got my molar mass. All right, now I don't know if you remember, I'm going to go back in page 4. Okay, do you remember down here? All right, we found, there are 40.08 grams of calcium in 1 mole of calcium, but what did I do down here? Water is not on the periodic table. Carbon dioxide is not on the periodic table. So you remember what I did? These are molecules. So how did I approach this? Well, that's what's coming up, okay? So let's go and back to the page we're on, right here, okay? So here we go. Carbon monoxide. Oh, that was from chapter 6, I believe. This is a nonmetal. So what's the formula of carbon monoxide? Carbon, I don't have any prefix, so it's just 1 carbon. And I have monoxide. What's the prefix mono mean? It means 1, so it's CO. So, that's my formula, is CO. Why is that important? All right, because I need to add up the mass of the carbon and the mass of the oxygen. So watch what I do. I have 1 carbon, and each carbon was 12.01 grams, right? Where did I get that? Oh, that's up here, right? Here it is, 12.01. All right, but what about oxygen? I have 1 oxygen in my formula. These numbers here represents the number of elements in the formula. So let's see here. Here's oxygen. What is its mass? It's 16. All right. And if I were to add those two numbers up, well, what's 12.01 plus 16? I believe it's 28.01 grams. So the mass of 1 mole is 28.01 grams. All right, so the molar mass is 28.01 grams per mole. That's the unit. Molar mass's unit is grams per mole. So the mass of 1 mole is 28.01 grams. All right, let's try the next one, carbon dioxide. All right, so I'm going to put a little C here. That means covalent. I'm going to put a little C here, which means covalent, which is non-metal. Non-metal. Remember doing that? Non-metal, non-metal. All right, so I have one carbon, and dioxide means two oxygens. Do you remember why we spent so much time naming? So we can do this, right? So the formula again is CO2. And let's see here. I have how many carbons? I have one carbon, and each one was 12.01 grams, right? And then I have two oxygens now, right? So the two oxygens, the two here means two oxygens, and it was 16.00 grams again. And if I were to get out my calculator, I get 44.01 grams. So 1 mole of carbon dioxide weighs 44.01 grams. And I want to do something real quick for you. So the fact that I have one of each, that's where these numbers come from, right? The fact that I have a 1 here, and there's where my 2 goes, okay? Well, what about sucrose? There's sucrose right here. I gave you the formula, all right? So how am I going to figure this one out? Well, why don't you try it real quick, all right, and then see what you get. Pause this. All right, welcome back. Hopefully you figured it out. So what did I do here? Well, here's my formula. So how many carbons do I have? I have 12 carbons at 12.01 grams, right? So watch this. Here's where that 12 goes. Okay, then what? I'm going to add, add. Oops, you didn't see what I just did. I'm going to add the masses. So I'm going to add, sorry about that, 22 hydrogens, right? And look up hydrogen. You'll probably get to memorize some of these pretty quick. Hydrogen is 1.01. We're going to use it a lot. All right, and that's where this 22 goes. Okay, and then what? I have 11 oxygens, and we already said oxygen was 16, right? And I'm going to do this. That's where the 11 goes, is right there, right? So if I were to get out my calculator, okay, here's my calculator. So I'm going to take 12 times 12.01 equals plus 22 times 1.01 equals plus, 11 times 16, and I get 342.34. Okay. By the way, there are no sig figs here. Why not? Because we are not measuring anything directly. I'm just reading off of a chart. Okay. So by the way, sucrose is also covalent. Okay. Sucrose is covalent. So what about sodium hydroxide? That's a metal and a non-metal. What kind of a compound is sodium hydroxide? Oh, it's ionic, isn't it? Why is that important? Because I need the formula for that. That's our last unit we just did. So what's the formula for sodium hydroxide? Well, I need my periodic table again. Here's sodium. What's the charge of sodium every time? It's an always, always. It's a +1, isn't it? So I'll put a +1 here. But what about hydroxide? Is hydroxide on this chart anywhere? No, it is not. So what do I do to figure out what hydroxide is? I need something else, don't I? I need my polyatomic ion sheet, don't I? Well, it just so happens I have my polyatomic ion sheet, and it's right here. So what is hydroxide? Do you see it? Here's hydroxide right here. Remember that? OH negative, okay? So this is OH negative 1, and now what? Do my charges cancel out? And the answer is yes. So you just write down NaOH. Okay? So now what? I need to look up sodium, oxygen, and hydrogen, don't I? So what is sodium? Here's sodium. Sodium is 22.99. And I have, oops, grams. I almost forgot the grams. Only got one of those, right? So if I don't put a subscript down, guess what? Isn't it a 1? And then I'm going to add 1 oxygen, and I already know I have oxygen in all of these, don't I? 16.00 grams, and that's my 1 oxygen, right? If I don't have a subscript, it's a 1. And then I have 1 hydrogen at 1.01, and now I'm going to add all those up, okay? Oh, I didn't do that. They're all 1s, right? So, ready? What is 22.99 plus 16 plus 1.01? Looks like 40 exactly, isn't it? So it is 40 grams. So 1 mole of sodium hydroxide has 6.02 times 10 to the 23rd, let's say molecules. That's actually called a formula unit, but I'll just use molecules, same idea. And it weighs 40 grams, okay? What about the next one? Copper. Isn't copper a metal? It sure is. Oh, so it's going to be ionic, isn't it? So, oh, copper is wishy, isn't it? Excuse me. It has a +2 charge. So what's the charge of hydroxide? I already looked it up once. -1. So what's the formula for copper 2 hydroxide? Well, do the charges cancel? No! What do we have to do? We have to crisscross, don't we? So we end up with 1 copper. I'll put a little 1 down here. And how many hydroxides? Oh, we need 2 of those. So I need to put parentheses, OH2. Now, we haven't seen this yet, have we? There's something you got to think about, okay? Why are those parentheses so important? Well, let me ask you something. I'm going to go on the top up here. If I had 3 times x plus 2, in your math class, what would you do? Wouldn't you say 3x, I'm going to multiply, right? 3x plus 6. Isn't that distribution? I distribute that 3 for everything that's inside the parentheses, don't I? Well, guess what we're going to do here? We're going to do that same distribution for this. Let me kind of center this a little better. There we go. I'm going to do that same distribution for here. So I have 1 copper. Didn't we do copper once already? Yeah, we did on top. So it was 63.55 grams. Now be careful. How many hydrogens, no, excuse me, how many oxygens do we have? Well, I have to distribute, don't I? So if I do this, I have 2 oxygens at 16 each. And if I distribute again, I have 2 hydrogens at 1.01. That's why those parentheses are so important. So I have 1 here, 2 here, and 2 here. Okay, so let me get out my calculator. Here it is. I'm going to clear this off. So now I have 63.55 plus 2 times 16 equals plus 2 times 1.01. All right, I got 97.57. Okay, and there we go. So what does that mean? I hope I did it right. We have in 97.57 grams of copper 2 hydroxide, we have 6.02 times 10 to the 23rd molecules or formula units of copper 2 hydroxide. Okay. Well, let's do one more. Why not? Let's do aluminum sulfate. I'll show you why I want to do aluminum sulfate. So again, this is ionic. Aluminum, well, what's the charge of aluminum? I don't have a Roman numeral by it, so it must be an always, always. Well, here's aluminum. It is a +3. All right, and sulfate. All right. Oh, that's a polyatomic, isn't it? So I need to go look it up on the polyatomic ion chart. So, if it ends in 8, it's always a polyatomic ion, isn't it? So over here is sulfate. Do you see that? SO4, 2-. All right. So this is a -2. So do the charges cancel out? And the answer is no. So what do we have to do, everyone? Let me hear it. Crisscross. Hey, you're right. Let's crisscross. Crisscross. So how many aluminums do I need? 2. How many sulfates do I need? 3. Okay, so now what? Well, let's do the same thing again. How many aluminums are in my formula? 2. And that was 26.9 something. What was it? 26.98. Now, remember how we had to distribute? How many sulfurs do I have? Well, 1 times 3 is 3. So I have 3 sulfurs. And we haven't done sulfur yet, have we? Sulfur is right here at 32.07. Now, watch carefully. What do I do here? Let's go back. What did I do up here? Did I add the 3 and the x, or did I multiply the 3 and the x? Did I add the 3 and the 2, or did I multiply the 3 and 2? I multiplied, right? That's where that 6 came from. So what do I do with the 3 and the 4? Do I add the 3 and the 4, or do I multiply the 3 and the 4? Well, what do you think? Yeah, we're going to multiply. All right, so 12, isn't that what 3 times 4 is? Yeah, that's 12. And again, it's 16.0, isn't it? All right, and let's add this up. You ready? Let's do this. So this is going to be a big number, I think. So here's my aluminum. So I have 2 of those. So 2 times 26.98 plus 3 times 32.07 plus 12 times 16. And I got 342.17. And so that means, oops, you can't see that. If I have 1 mole of aluminum sulfate, there are 6.02 times 10 to the 23rd particles of aluminum sulfate, and it's going to weigh 342.17 grams. Okay? And that's how you do molar mass. So what I would like you all to do for me, all right, is take a picture of all your work, put your name on the top, by the way, and upload it. See, there's, you can put your name, and upload it to Google Classroom. All right? Then what? Go find, here we go, molar mass. This is 7.3 practice. Oops, there we go, page 3. All right, I want you to do this. Hey, I've already given you the formula, so there's no excuse, all right? But this time you're going to name them, all right? And fill us out, put your name at the top, and upload this to Google Classroom, all right? So that is your virtual assignment for me, so don't wait to be great. We'll see you next time. Bye, everyone.